All right, so we have, I want to start with 1.8, which is inequalities. So for example, if you have something like 4x plus 7 is less than equal 19, then one thing you could do is, in order to solve this, and so this is an inequality, so it's like an equation, but it's more like anything less than, like 4x plus 7, anything less than that. First of all, like, let me give you a little like reasoning why do we care about inequalities. So there are topics like linear optimization and non-linear optimization in finance, in businesses, big corporations, essentially like finding profit and loss. Or like, let's say you have a manufacturing business, you have certain like fixed costs, you have labor costs, you have material costs, and then you make things and then you sell them. Like, there's always this question, should I expand and get more workers and get more material to build more, but am I able to sell them? And then, so just running a business, there's like hundreds and hundreds of variables available to optimize like how your business is running. In fact, there are people that their specialty is to optimize businesses, especially big corporations, because they can afford to pay someone to analyze that. So these people go and literally go through the whole business like no one else's business. Like they audit the whole thing. They audit how much like labor costs. Are the workers being efficient, or is it too many guys just hanging out and chit chatting? Or they talk about material. They talk about like transportation, packaging, sales, advertising, marketing. Every single one of those become a variable like X or Y or Z or however you want to call it. Then they come up with like these giant equations, sometimes systems of equations that are in equality form. Like, we want to have profit, so we want to be more than this. This is our fixed cost, so our sales need to be more than our fixed cost. So they have all these equations or inequalities, let's put it this way, and they can solve it. When they solve it, they don't have one answer. They have like a region of an answer. Like, they have, if you produce from this much to this much, you're in a green. If you produce less than that, you're going to lose. And more than that, you're going to waste, profitability. So this whole thing is called linear optimization. It's like a fourth year course. If you ever take it, if you ever go on to 4-year university, you could take that. Or there's another one more advanced called nonlinear optimization, which people like literally write very complicated equations to find out what is good and what is not good for these businesses. It is the most paid job for like undergrad or master degree math like level, just because you can make a lot of money for people and they'll have to share it with you, like, essentially. When I was at UCSD, the professor that I had that was kind of like a nonlinear optimization guy, Philip Gill, he was multi-millionaire, but like not just like a few million. Like, I think he worth about 400 or 500 million dollars, just because he wrote packages and sold them that it would optimize, you know, things for other companies. And that's what he did. He was a well-known mathematician. He was a British guy. So just letting you know, this topic may seem useless right now, but it's actually like one of the most used, part of mathematics in the industry. Not so much like, I would say, science, but like more of industry kind of the path. Because that's like, you can go different path when you study math or finance. So anyway, so how would you do this? You solve it just like how you would solve a regular equation. However, you just have to be respectful to the signs. So you can add a constant or subtract a constant to both sides, and this doesn't change. So then you can take 7 to the other side, so 4x would be less than 19 minus 7. So 4x is less than 12. And then you can divide by 4. But because it's a positive number, you're not going to flip the sign. So then x is less than equal 12 divided by 4, which is 3. So that is the solution. It's not just one answer, it's a whole region. And if you draw it, this is your number line, this is your 0, this is your 3, this is your x-axis. Then anything less than 3, including 3. So you put a solid dot, and then that's the region that the solution is for you. So there's some rules on how to deal with these equalities and inequalities. So I'll write out a few of them here. So rules. You can add or subtract a constant and it wouldn't change the sign. So if a is less than equal to b, then you can add or subtract c. A plus minus c is less than equal a, b plus minus or c. So you can add or subtract c from it, and it wouldn't change the direction of your inequality. So a is less than equal to b and c is positive, so you're multiplying the whole thing by a positive number, that wouldn't change the inequality. So then CA is still less than equal CB. So you will not change how the inequality changes because your scalar, what you multiplied by, was positive. So if you multiply the whole inequality by a positive number, it wouldn't change the direction. Again, if A is less than equal to B and C is negative, then because you're multiplying by a negative number, it actually changes the direction of your inequality. So CA is going to be bigger than or equal to CB. For example, 1 is less than 5, but -1 is bigger than -5. So that's why it changed it, because you multiply it by a negative number. Next one, if A is less than equal to B, what if you flip both of them, like you put them in a denominator? Then it changes the direction. So then 1 over A is bigger than equal 1 over B. So as an example, 2 is less than 3, but then 1 over 2 is bigger than 1 over 3. And then the last property that I want to put in is if A is less than equal to B and B is less than equal to C, then A is less than equal to C. So it kind of it's a transitive property. Question? But these are, I wanted to kind of get into a little bit more complex inequality and figure out like the solution set and so we can kind of go from there. Let's do an example, and I want to go over the details of it. So let's say we asked you to solve this inequality, x squared is less than equal 5x minus 6. So the question is, where on the x-axis, for what values of x squared is less than that line? So what is x squared? X squared is like a parabola. 5x minus 6 is a line. Where is it that that parabola is less than that line? All right. And things could get complicated quite quickly. So graphing is definitely an option. You can graph it and pinpoint where those points are. But it's better to do it with the algebraic method to figure out where this inequality holds, and then that's the answer. So typically when you solve inequalities, your answer is on the form of an interval. It's not like just like 1x. It's this region works. This region works such that, you know, this x squared is less than 5x minus 6. So the best way to do this is to actually use the techniques that we've learned so far, like factorization, and simplifying the expression into multiple factors. So then you can figure out the sign for each factor, and then you can figure out the answer. So I'm going to go through this in detail. It might be new for you because the way I'm doing it is a little bit different than what some of the teachers teach here. But then if you're comfortable with the previous way that you've learned, that's okay too. Or if you want to learn this method, you know, I really like it. Or it might be the same thing that you've learned before. Who knows? So the way I deal with such an inequality here is I put everything in one side. So it would be x squared minus 5x plus 6 is less than or equal to 0. So all I did was I moved all the terms into the left side, and I said I kept, you know, the inequalities positioned the same way, because all I did was I subtracted and moved things to the left. So I didn't have to switch the sign. And now I need to solve for x such that this expression is less than or equal to 0. So I'm looking for 0 and negative parts of this parabola. All right. How do I go forward with this? I want to see if I can factor this, because if I can factor things and take them into a single like a exponent of power of 1, it is easier for me to figure out where it's positive and where it's negative. So I will factor this. So I need to find two numbers that when you add, you get -5, you multiply, you get 6. That's x minus 2 times x minus 3 is less than or equal to 0. So all of a sudden, this is a lot easier to kind of look at and see how we can find the x's such that this whole expression is negative. When do you remember when we were talking about what happens when you multiply a positive number by a negative number? It's negative. And what happens negative times positive? It's still negative. But if you multiply two negatives, it becomes positive. So think about this. You have a factor times another factor. Where is it that one is positive, one is negative? And where is it that they're both positive? And where is it that they're both negative? So if you find that information, you can kind of combine and find the region that works for you. But it would get messy quickly because you have all these options, right? So the best way to deal with it is to actually create a table. It's called a sign table. So the sign table, what it does, it's a table that you have your x. It goes from, and if you have never seen this before, just bear with me. It's not complicated at all. It's just a way to organize your things. So you have the first line here this is kind of like your x and goes from negative infinity to plus infinity. Now, there are some important points here. For example, look at this x minus 2. Where is it 0? Is at 2, it's 0. And this x minus 3, at 3, it's equals 0. So right at 2 and right at 3, those guys will change their sign. So what the next thing you do is you put out all the zeros. Listen to this. All the zeros of your factors on the top. And you have to have them in order because we start from negative, we enter the positive. So then we have 2 and 3 as two critical points, I call it. It's a critical point because it changes things in my equation. So these are the zeros of your, so x minus 2 equals 0, x is equal 2, and x minus 3 equals 0, x is equal 3. So these are your 2 points that you have. Then this is what I do in the sign table. Each line after this x, so I did my x line. The next one would be one of the factors, and the second line would be the other factor. So each line in this table represents one of those factors that we had in the multiplication. So we have x minus 3 is right there, and then x minus 2 is right there. But then we care about like where it's 0, where it's positive, where it's negative. This is called a sign table, right? This is called a sign table. So I want to know when things are positive and when things are negative because I want to summarize the whole thing. So here you go. I got x minus 2 is 0 at x equal 2. And I wrote 0 right below x equal 2 here. When on the left side of 2, so like things like negative, like 1 or 0, x equals 0, if you put like any of those numbers here, this value, this x minus 2, will be negative. Just think about it. Like put any numbers before 2. X minus 2 is negative. At 2, it's 0. And then anything more than 2, it's positive. It's positive after 2. Like if you put in 3, 3 minus 1 is 1, it's positive. If you put in 4, it's positive. So anything after that, it's positive. So important things here are these points here are not just random. They're critical points. They're the points that make your factor 0. It starts from negative into infinity to plus infinity because that's what the domain is. And each line of the table represents one of the factors. And then we just find out their sign. The next one is x minus 3. So x minus 3 is 0 here. Anything less than 3, like you put in 2, 2 minus 3 is minus 1. So everything below that is negative. And anything more than 3, it's positive. So the nice thing about this table is you can actually like summarize everything at the end. So what was your entire expression? Your entire expression was this thing, right? Was x minus 2 times x minus 3. So essentially all those factors multiplying will go to the last row. Now you can tell me when things are positive and when things are negative and when things are 0. So if any of those guys are, if x minus 2 is 0, the whole thing is 0. So right here, it's 0. If x is equal 3, that multiplication here is 0 also. So like, because that factor is 0. You're multiplying x minus 2 by x minus 3. And in this region from, so this region is the region negative infinity to 2. This region. In that region, you have 2 negative factors. And when they multiply, what happens to them? Becomes positive. At x equal 2, it's 0. So 0 times anything is 0. So then you get 0 over here. What is this interval? This is the interval 2 to 3. And 1 is positive and 1 is negative. So then that makes the whole thing negative. And then at 3, x minus 3 is 0, so the whole thing is 0. And then more than 3, they're both, this is the interval 3 to infinity. They're both positive, so when you multiply them, it's positive. So now you found where this expression here, or this thing that we factored, where it's negative and where it's positive. What did the question was looking for? The question was looking for x's such that this entire thing is either equal 0 or negative. So that means your solution is that, where it's negative and it's 0. So it's between 2 and 3, also including 2 and 3 because it made it 0. So the solution is it's a set of x such that x belongs to the interval 2 and 3. Or you can rewrite it as x such that x is between 2 and 3. They're both the same thing.
On the test, if we just put the brackets or the hard inequalities sign, like the equal to sign, will that be okay, or do you want the whole x belongs to said value?
It would be nice to write it as a complete form because you're saying my solution is a set.
Okay.
So your audience is more aware of like, oh, okay, it's a whole set.
It's not x and all. Okay.
Yeah.
Okay.
So it's a whole set of numbers. It's like this whole interval,
Okay.
you know. Few things that I've seen people making a mistake. First of all, understand that this top row is just your x interval. It's just like, this is my x's. These are my x's. These are my important x's. So these 2 and 3 here, it's not random. I actually picked them because they're zeros to my factors. They're called critical points. The other thing is, you have to respect, like, things needs to be lined up. So like, my table has like a whole discipline into it. If you don't line things up, you're gonna lose the positive and negative. The other thing that I've seen people do is they put so many like negatives here and so many positive. Like just put one, it's okay. Like just put one negative in this interval, one positive there and one positive there. So try to keep it simple so you're not like looking at this, you know, crazy table and try to figure things out. Any question on this? We'll do more of this example because I think it would be nice to see it. All right, next example. Solve x times x minus 1 square times x minus 3 less than or equal to 0. So this one, it's already been factored, which is kind of nice. You don't have to worry about factoring it out. Like last question, we had to factor it out, but this one it's already like factored out. And we can start finding those critical points right away, and then we can write out, you know, the table. So what are our factors here? One is x. If you set it to 0, x is equal 0. The other one is x minus 3 equals 0. Therefore, x is equal 3. That's another factor. And then this x minus 1, it has two of them, but we still need to find that 0, which is just x equal 1. But I know it's a power 2, but it's like 2 of that factor. You know, it's x minus 1 times x minus 1. So you still have this x minus 1 as a factor, and you find it's 0. X is equal 1. So if I do the table, this is my x. I go from negative infinity to infinity, and I have these 3 points, 0, 1, and 3. These are my critical points. And then my factors are x, or just, because that was like right there, you see that's x. So it's 0 here, negative before that, positive after that. And you see I put a positive between 0 and 1. I put a positive between 1 and 3. And I put a positive after 3. You can almost put some lines here so you know where you need to put your things here, signs here. Next one is the x minus 3. The factor x minus 3 is 0 at 3. And it's negative before 3, so it's negative, 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 and positive after 3. And then the last one is a x minus 1 square. I could just put an x minus 1 and then put another x minus 1. But I could just put one x minus 1 square because it's easy to deal with. It's always positive, right? Because it's a square. But it's only 0 at 1. So it's positive, 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 because it's square. So the last thing is to get the whole expression going, which is this entire thing. We call that, let's call that S, because I don't have enough room here, so I call that S here. So everything is getting multiplied here. If you look at here, from the interval negative infinity to 0, I've got negative times positive. So that interval will give me a positive result because they're all 2 negative and 1 positive. So that's positive. From 0 to 1, positive times positive. 1 negative, so that's negative. It's 0 here and it's 0 here. Positive times positive, that's negative there, and it's 0 here. And then positive times positive. Any questions so far? So the inequality is asking for what? Look at here. It's telling you find x's such that this entire s is negative. Not even equal 0, but just negative. So where are those? It's here and there. But not including these zeros. So your solution is this. The solution is a set of x such that x belongs to this interval 0, 1, and then 1 to 3. So union 1 to 3. Question.
How would we write that as an inequality? How would we write that as an inequality?
It would be x such that x is between 1 and 0, and then x is between 3 and 1. This upside down V means and. This is and. This is or.
Well, so the solution never will be infinity. Like,
Right. So in this
no
case,
inequality.
we don't include infinity because anything less than 0 is all positive, and here's positive, and we are looking for negative.
No.
So
Okay, it's the same.
yeah. Question?
Why is it and? Like when you said.
Because they both have to be true. They're both part of the solution. So it's this and that. So it's this interval. Let me actually write this too because I did not complete it. This is 1 to 3. This is 3 to infinity. So it's negative in these two intervals. So it's this interval and that interval. But if I put in a interval form, like it would be this union that, or you say this and that. They're both the same. I want to give you another example. Actually, why don't you try this for just a couple of minutes to see if you can do it. Solve 1 plus x, 1 minus x, bigger than or equal than 1. So let me give you some things to give you help on this. I'll give you like 5 minutes to try it, and it's a good time to like take a quick break too. But look at this thing. The sign table, this is very important, only works for positive and negatives. It doesn't work for like bigger than 1 or bigger than any other constant. So you must take this 1 to the other side so you have a 0 on one side. But when you take the 1 to the other side, then you have a whole like simplifying to do. Like you need to get a common denominator and put them all in one fraction and simplify it. All right? So that's the first thing you got to do. You got to take this to the other side, simplify it, and then go from there. The second thing you got to do is you have to be careful for x equal 1. You do not want to include x equal 1 in your solution, just like how we talked about it before. As soon as you have a denominator, you got to exclude x equal 1 from any of your solutions because it makes the denominator 0, which is illegal. So you want to just make sure you bring everything to one side, get a common denominator, then set up your table. Factor things out and set up a table. And then once you set up the table, you can figure out where it's positive and where it's negative, and then write the answer. So I want you to try this. This is like a very good test problem, by the way, or something similar to this. So try it and maybe work with your neighbor. Give you 5-10 minutes. If you need to go use, get some fresh air and whatnot, do that, use the restroom, and then I'll do this after. All right. So for this problem,
Do we record
yes, thank you. Thank you. For this problem, it's frozen. Again, the right-hand side is not 0. And if you want to do a sign table, you must have either less than equal to 0 or bigger than equal to 0. Otherwise, it's not a sign table. It's a table for 1. It's not a table for 0. So it's important to this thing to know that you have to have a 0. So in order to get there, we're going to bring 1 to the left. So it's going to be 1 plus x over 1 minus x minus 1 bigger than or equal to 0. Get a common denominator. So we have 1 minus x as a common denominator. This one stays at 1 plus x. So essentially what you're doing is you're multiplying and dividing this by 1 minus x and 1 minus x. That's what you're doing. That's what I mean by the common denominator. Now, you see this negative 1 here, that goes to the top there. So that's negative 1 minus x. So you can either say negative parentheses 1 minus x, or you can actually apply the negative to both. And that's still bigger than or equal to 0. So then the next step would be simplifying. You see, this 1 and that negative 1 cancels. And then you have an x, and then a minus minus x, which is plus x. So that's 2x. So then you have 2x over 1 minus x bigger than or equal to 0. So this is now what we need to put the table for. So our critical points are x equals 0 and x is equal 1. Also remember that at the end, you cannot have x equal 1 to be a solution. So x equal 1 cannot be a solution because it makes the denominator 0. So we just want to make sure we don't include that. So we can write up this sign table. We have x, we have negative infinity, we have 0, we have 1, and then we have plus infinity. So the intervals here are negative infinity to 0, 0 to 1, 1 to infinity. So then we have our factors, which is x. And then the other factor, you see that 2x, that's why I say x is a factor. And then we have 1 minus x to be another factor. And then we have 2x over 1 minus x to be the full expression that we're dealing with. So then we have that, yes?
Why isn't 2x like its own?
You could put 2x, but it wouldn't change the sign.
Okay.
You could put x or 2x, because 2 is positive.
Okay.
So you can, like the actual factor is x, but then the full expression is 2x.
Okay.
If it was negative x though, I would have to do the negative x because it flips all the signs.
Excellent.
So then x is 0 at 0, and it's negative before and positive after. And then 1 minus x is 0 here, negative before. No, actually, I lied. If you put in like one number smaller than 1, like 0, what happens? Like 1 minus 0 is positive. So it's positive here and positive there. And anything more than 1, like 2, like 1 minus 2 is minus 1. It's negative. So then you divide the 2. So you're dividing a positive to a negative. What do you get here? You get a negative. At x equals 0, your numerator equals 0. So you have a 0 here. You're dividing a positive by a positive, you get a positive. Here's the tricky one. You're dividing by 0 at x equal 1, you see? Your denominator equals 0. So what I usually do is I block it out. I kind of do, to just remind myself, that's a bad point. Because I don't want to have 1. Because it goes to the denominator and makes my life miserable. So, and then after that, you have positive divided by negative, so that's negative. So what are we looking for at the end of the day? Remember, this was, you wanted positive bigger than or equal to 0, right? That's what we were looking at. So when is it that you're bigger than 0 and positive? This one. Are we going to include 0? Yes. Are we include 1? No. Because that's a bad point. So the solution then is a set of x such that x belongs to 0, 1. So just pay attention. I included 0 by the square bracket. I did not include the 1 by parentheses. Question?
Up a bit, how did you go from like two? How did you get the solution like from 2x over?
Are you okay up to here?
Yeah.
And then, so those were my factors, right? So that's here and that's there. So then I want 2x over 1 minus x to be positive and equal, bigger than equal 0. So I have this. I need it, so where is positive and 0?
I'm still.
Which part of it?
I don't know, like.
Do you understand how each line is for one factor? So this x is 0 at 0, negative here, positive there. 1 minus x is 0 there, positive there, negative there. And when you divide those factors, when you divide that by that, you get this, right? So negative divided by positive is negative. Positive divided by positive is positive. Positive divided by negative is negative. So you have the intervals that are negative, and then you have the interval that's positive. So you want the interval that's positive because that's what you're looking for. You're looking for this to be positive. All right.
I had a question.
Yes.
There's another way, I could be wrong. Could we solve it by just plugging in, like using a chart, but plugging in a bunch of different numbers for the x value and seeing what is true and what isn't true?
You could, but it's not efficient, and you're going to end up making a mistake because what if you miss something? This is a very systematic way where everything is accounted for. You're accounting for all the factors and all the negatives and all the positives. Everything is there. So I think it's good to submit and learn the table. Yeah, it's a good table because we're going to use this again. So when we go to the section where we have to graph a rational expression with all the asymptotes and go to infinity, and and some like you have a horizontal asymptotes and vertical asymptotes and all that. All of those, we use the same table because it helps me find like, oh, it's going to go blow up to positive infinity or blow up to negative infinity, or I have this horizontal asymptote. So when we graph those, then this table becomes quite handy, which we'll use again. So I think it's very important that you know this table, sign table. Book has something very similar to this. I don't know who had a chance to read 1.8. So, because I asked you guys to read it, so it has a very similar table if you've read it. So, the next thing I want to talk about is inequalities involving absolute value, which is, it could get tricky a little bit, but it's not too bad. So it's just a couple of rules that we need to have and we need to know, and then from there we can solve them. So, properties of absolute value inequalities. So essentially there's just two main rules. If x is less than or equal c, that is equivalent. So this is how I write equivalent with 3 bars. It's not equal, it's equivalent to x is between c and negative c. Think about it. If I say x is less than 2, the absolute value of x is less than 2, the result, like, what numbers works here? Like 1.5 works, right? Does negative 1.5 works? Yeah, because you absolute value it, it becomes positive. So 1.5 works, negative 1.5 works, 1.9 works, but 2.1 doesn't work. So it's just between negative 2 and 2. So when you have an x, an absolute value of x less than or equal constant, x is between those two. Second one, so this is the same as x is between.
It doesn't include 2, right? Does it include?
So if it includes it, you include them. If it doesn't, then you don't. So just like that. 2, what if your absolute value of x is bigger than or equal to c? Then you kind of partition it. You say that x is either less than or equal negative c, or x is bigger than or equal to c. So this means or here. Here's an example. Absolute value of x is bigger than 2. So what numbers work? Like 2.5 works, 3 works, right? 4 works. So anything more than 2 works. But what about like negative 3? Absolute value of negative 3 is 2. So it works. So anything less than negative 2 also works. Like negative 4, negative 5. All those numbers work. So x is bigger than 2, or x is less than negative 2. So those are the two set of the set that works. If you were to see it in the picture here, this is your 0, this is your c, this is your negative c. So it's like either including or not including. It would be somewhere in the between when absolute value of x is less than c. But then when it's more than c, then this is your 0, this is your c, this is your negative c. Then it's like outside of that area. I kind of put it shaded here because I don't know if I should include the points or not, but it's like when it's like that, when absolute value of x is bigger than c, it's outside. When it's less than c, it's inside. So then let's do a problem now that we know the rules. Solve absolute value of x minus 5 less than 2. So then immediately you can say this. You can say absolute value of x minus 5 less than 2 based on this rule that I just learned. You see this rule here? If it's less than or equal to c, it's between them. So then you say that this is equivalent to say that x minus 5 is between 2 and negative 2. So I write the equivalent format of that. Then I solve it from here. How do I solve it? It's not difficult at all. I just add 5 to everything. So I add 5 here, I add 5 here, and I add 5 here. So then you end up getting x is between 7 and 3. And that's your solution. Yes.
So the very first one of absolute value of x is less than or equal to c.
Yes.
Would that not, why is that not negative c is less than equal to x?
So that's the equivalent definition. So we're saying if the absolute value of x is less than c, this is equivalent to x between c and negative c. And we did an example like if x is less than 2, if absolute value of x is less than 2, only the numbers between 2 and negative 2 works out. For example, if you put x equal 2.5, that's not less than 2. Or if you put x equal negative 2.5, that's not going to work out. The only numbers that would work is between negative 2 and 2.
Yeah, but why isn't it less than equal to?
For the C, you should have.
Oh, I'm sorry, I didn't get your question properly. Yes, it should have had the equal sign.
Okay.
Yeah, thank you. Another example. Solve absolute value of 3x plus 2 bigger than or equal to 4. So then this is following the rule that we just put in. We said if absolute value of x is bigger than or equal to c, that's equivalent that x is less than negative c or x is bigger than or equal to c. Right? So this has that format. So then 3x plus 2 bigger than or equal to 4, that's the same as 3x plus 2 less than negative 4 or 3x plus 2 is bigger than or equal to 4. So we have two separate inequalities that we have to solve. But then now it's not too bad. So then you can solve this one separately and solve that one separately. So 3x is less than or equal to negative 6. So x is less than or equal to negative 2. Or here 3x is bigger than or equal to 2, so x is bigger than or equal to 2 over 3. So that's your solution. Any question?
Just go up to the properties one more time. Thank you.
I'm going to give you one problem to do that involves the table, which because I think it's good for you to practice it one time again, and then give you time to do it, and it's not complicated at all. Let's do that, and then we can move on to the next section. solve this inequality, which is x plus 2, x minus 1, x minus 3, less than equal to then 0. So solve this inequality using the table and write the answer in an interval form. When you finish, come and show me your work. And then when a bunch of people finish, then I'll start doing the problem. First of all, this is your homework for this section for 1.A. Yeah, move it down so I can. So what I'm doing now is I'm just finding the zeros for each factor. So x plus 2 equals 0, then x is equal minus 2. X minus 1 is equal 0, then x is equal 1. X minus 3 is equal 0, then x is equal 3. So then I need to draw the table. So the first one is just x interval. So it goes from negative infinity to negative 2 to 1 to 3 to plus infinity. These are my critical points on x. So I have these intervals. I have this interval like negative infinity to negative 2, negative 2 to 1, 1 to 3, and then 3 to plus infinity. These are my intervals that are in that area. Then I have the factors. So I have x plus 2, I have x minus 1, and I have x minus 3. And then I have the whole thing, which is multiplication of all of them, which is x plus 2 times x minus 1 times x minus 3. And I have these zeros here. So x plus 2 is 0 here, x minus 1 is 0 at 1, x minus 3 is 0 at 3. For x plus 2, it's negative before negative 2, and it's positive after. For x minus 1 is 0 at 1, so it's negative before and positive. You have to double check. Don't just blindly put negative on the left, positive on the right, because if this was in 1 minus x, the whole thing would have flipped. So if you have a positive sign behind the x, this holds, but if you have a negative sign behind the x, it changes. So you have to double check. For example, you can put in a negative 2 here and put in negative 2 minus 1 is negative 3, so it's negative here, you know. And then x minus 3 is 0 there, negative before, positive after. So I lined everything up, all my signs are there. Now I can go to the end result. There's no denominator here, so everything works. So I have 0 here, 0 here, and 0 there. And in fact, with my solution, I want to include the 0 because it's telling me that less than equal to 0, so I want to include the 0. And if you look at the signs, I have 3 negatives multiplying, so that's negative. Positive and 2 negative, that's positive. 2 positive and a negative, it's negative. And then 3 positives, so it's positives. So then, what are my intervals that's gonna work for me? I want to be less than equal to 0. So that's this interval. And then also that's that interval, including the zeros. So then my solution will be is a set of x such that x belongs to negative infinity to negative 2, including the 2, union 1 to 3, including 1 and 3, because I'm allowing 0. That's one way to do it. The other way to do it is x such that x is less than equal negative 2, and x is between 3 and 1. So that's like a different way of writing it. How many of you are following me? Good.
So if it's no, like, if that don't include the 0, we don't need to put the one with the minus infinity, right?
So for 0, if it's including the 0, you either put the square bracket or you put the equality. If it's not including the 0, like if it was just less than 0, then you put parentheses here.
But we still have two solutions, or just one?
Just to still have two solutions. Yeah, because it's just like whether you're including 0 or not.
Oh.
And if this flipped, like it was like bigger than equal to 0, then there would be the solution, you know?
Mm.
So for that first part of the solution, the negative 2 has brackets after it because you're including it, which means you're including 0.
Correct.
Okay.
Exactly.
Okay.
Exactly.
Why did you do the and?
Because it's both. It's an inequality. So like it's this area and that area.
So both
So I
of
have
your-
two set of solutions combining. Yeah.
Is or just when they can't happen at the same time?
When you have like typically when you solve like inequalities, you want to include both at all the time, so you use and. But if you're solving just a simple equation, it's either this solution or that solution. So
On the test, would both solutions be fine? to use?
yeah, either one is fine. Either one is fine. All right. Moving forward, so we're gonna kind of go through the coordinate systems and whatnot. There's a couple of things that I want to review. One is like the distance of a line in a two-dimensional space. The other one is midpoint. The other one is like equation of a circle. So these are just like basic things that we just need to know. So the first one is the distance formula. So if you have 2 points, so let's put our x and y axis. So we have it in x-axis and then we have an y-axis. And we have 2 points. We have this x1 and y1. And we have this other point x2 and y2. And we want to find this distance here connecting these guys. So it's actually just using the Pythagorean theorem, we can find this distance quite easily. So if you think about it, this is your x1. This is your x2. So this distance here is what?
Since we'll be
Or x2 minus x1 if it's like bigger, x2 is bigger. And then we also have this other thing here. Let me move this. So then we have this thing here, which is y1 and y2. So this distance here is y2 minus y1. So So if you think about it, we have this rectangle here. If this is your D, if D is the distance between the points, so you have a point x1 and x2, you have a point x2 and a y2, you want to find a distance between those 2 points. If you look at this Pythagorean theorem, if you look at this triangle, sorry, this is a right triangle. This is a right triangle here. This distance, we have it, bless you. That's y2 minus y1. And then that distance is x2 minus x1. So we have, in this triangle, we have the height and the width. We can find this d here by using the Pythagorean theorem. Remember with the Pythagorean theorem what it was? In a right triangle, if this is a, b, c, c squared is equal a squared plus b squared. Remember that? So we're gonna use that to figure out this d. So then our d is equal so d squared is equal x2 minus x1 squared plus y2 minus y1 squared. So what is d? Well, d is the square root of that. So you just remove the square. So that's your formula for the distance. Question? So like if here's an example. Find the distance between the points one, 2, and 4, 5. My suggestion is you name them. Call this one x1, y1. Call this one x2, y2. So that you don't get confused. You can follow the formula. So d is equal y2 minus y1 square plus x2 minus x1 square, which is equal 5 minus 2 square plus 4 minus 1 square, which is equal, that's 3 square, that's 9, and that's also 9, so it's square root of 18. That's your d.
I noticed that you kind of like flipped it from the when you wrote like the initial.
Yeah,
does it
because
matter? Does it?
because a plus b is equal b plus a.
Oh.
Yeah. Question? The next thing I want to talk about is midpoint. So now you have 2 points again. You have x1 and y1 point, and then you have x2 and y2 points here, and then you connect them. The midpoint is the point that's in the middle of that line. How do you find it? Just averaging. That's the middle point. So then this is x1 plus x2 divided by 2. That's that point. And then this point is just y1 plus y2 divided by 2. That's the midpoint. It's called the midpoint. So if the question is to find the midpoint of 2 points 1 and 4 and 2 and 5, then the coordinates of that, we call that the midpoint, or M, is 1 plus 2 divided by 2 and 4 plus 5 divided by 2. So that is equal this point of 3/2 and 9/2. That's the coordinate of that midpoint. So is the coordinate of midpoint. You guys seen these before, right? Yeah. The next thing I want to talk about is intercept. X-intercept and Y-intercept. It's important to know because when we go to chapter 1 or chapter 2, we need to find intercepts quite a bit. So I want to talk about that. So the next thing is X and Y intercepts. And it's a very easy concept. You just have to like fully understand what it is, and then we go from there. So let's say we have this like parabola here. Like let's say y equals f of x. This like is just a function, is just a graph that we have here. I don't even care what it is, but I just want to talk about the intercept. What are these points? This one and that one.
X-intercept.
It's x-intercept. It's where we cross the x-axis. So this is x-intercept. That is also an x-intercept. This one here is what? Is y-intercept. Because this is the y-axis. This is the x-axis. All right? Can someone tell me if you're looking at x-axis, what are your y values? Every x-intercept, like listen to this, every single x-intercept is found by setting y equals 0. So it's the other opposite one. So y is equal 0 here, and y is equal 0 here. Because this is your x-axis. So you have no y. So in order to find x-intercept, you set x equals 0. To find x-intercept, set y equals 0 and solve for x. That's the first one. What about y-intercept? Like if you look at this y-intercept, what is the x value for it?
0.
Because it's like right on the axis, so x is equal 0 for here. To find y-intercept, we set x equals 0 and solve for y. So that's the gist, that's the basic of it. Like you just have to do that. Let me do an example. Find x and y intercepts of y equals x squared minus 2. So for x-intercept, we set y equals 0, which means 0 is equal x squared minus 2. Therefore, x squared is equal 2. Therefore, x is equal plus minus root 2. Those are our x-intercept. For y-intercept, we set x equals 0. So y is equal 0 minus 2. So then y is equal minus 2. So that's our y-intercept. In fact, if you graph this, you'll see that it's a parabola that starts from -2, goes up like that. And that's root 2, and that's negative root 2. So it's always, for x-intercept, you set y equals 0. For y-intercept, you set x equal to 0. Any question? So I want to give you some homework problems for 1.9 also. But here's the thing, you may have to read some things like equation of a circle, which you've done many times before, or I don't know what else you might have to read. Like, it's all pretty much covered. But I wanted to give you some exercises to do. And if you had any question, come and see me in the office hour, and then or just come and see me during the class. But they would be like homework for 1.9. $25. So question 91 and 93 are really beautiful questions that requires you to use completing the square method that we went over with. So please try those. Those are very nice problems. And then for next time, read section 110. It talks about slope and equation of the line, parallel lines, perpendicular lines, and how to write the equations. So definitely read 1.10 and 1.11 for next class. And then the following week we'll start with chapter 2. So chapter 1, all of it will be in the first test, plus a little bit from chapter 2, whatever I get to cover on that Monday. And then on Wednesday, on Wednesday most likely I will start chapter 2, and then a little bit more on Monday. And then the sample test which I give you on Monday will kind of show you the type of questions. So if you have any questions, I'm here for another 10-15 minutes. I'm gonna chat. Otherwise, I'll see you Wednesday.